Welcome to the Math Record. Today I'll be covering the ICTM State 2014 Division A Geometry. I'll be going through every single question from 1 to 20 in that order, and I'll be also putting them in the description if you want to look for a specific one. Okay, number 1. Given circle P with tangent BC, secant B, and diameter DB, and if the measure of ABC is 35 degrees, find the measure of arc AD. Okay, so we have something like this. Not the best drawer alive. Good enough. And then we have a line here and a line here. And they said this one was 35. So since this is 90 degrees, right, because it's tangent, then 90 minus 35 is 55. And if you know inscribed angle and lines, which is really simple, if your inscribed is half of your arc. So if this is 55, then this is going to be 110. And that's your answer for number 1. Okay, number 2. Given two triangles, find the largest number of corresponding pairs of segment or angles that make them be congruent without two triangles themselves being congruent. Okay, this is something you just need to know. It's actually just 3. And the reason is because you ever heard of like the side, or angle, side, angle, or like side, angle, side, etc. stuff, right? There's one case where it's technically not proven congruency is angle side side or side side angle. And the reason is because if we have a triangle like this, and then we have a line, another line, right? We have this. Basically, this side length could be reflected over this line to over here, basically, to make that line. So basically, this triangle could be made into two triangles, which satisfy a angle and a side, or this side could also be on this side. So they're two different triangles, but they have two same side lengths and one same angle. So it corresponds with the 3, but they're two different, and that's the maximum amount. And you can't go higher than it because if you go to 4, you either have 3 side lengths, which means the triangle is the same, or you have 2 side lengths and 2 angles, which means the third angle has to be the same because two angles are already the same, and you have 3 angles which are the same, which means it's congruent. So basically, no matter what, 4 and higher has to be congruent. So the maximum you can have that are not is 3. And that's your answer. Number 3. Define a mid-diagonal to be a segment connecting a midpoint of one side of a polygon to a vertex of the polygon other than the two vertices that are at the endpoints of the side on which the midpoint is located. Find the number of mid-diagonals of an octagon. So let's kind of draw an octagon. Okay. So a mid-diagonal is basically we take the midpoint of a side, and then mid-diagonal is from that point to a vertex, right? And there's here, 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 and here. So we have 1, 2, 3, 4, 5, 6. It's not going to include these two, but it's already connected to it. So there's 6 of them. So how many are there in total? Well, there's 8 sides, so if there's 8 sides, that means there's 8 mid-diagonals, right? So each of them has 6. So 6 times 8, that is a total of 48. And that is your answer for number 3. Basically just that simple. Number 4. If triangle ABC, in triangle ABC, the measure of A is 1/3 the measure of C. So let's kind of draw something like this. So ABC, and if the measure of C is X, then A is 1/3 of X, and a half of B. So that means this is 2/3. So now, if this entire triangle is 180, right? So 2/3 plus 1/3 plus 1, that's 2. So that's 2x is equal to 180. So x is 90. So this tells us since this is x, that means it's a right triangle. So let's kind of rewrite this. And this is our C. And our A is 1/3 of that, so that's our 30. And our B is going to be our 60. So if AC is k square root w, okay, and we need to find the length of AB and BC, AB and BC, and the sum of those is less than 30. And if W is as small as possible, find the sum of all possible values K. So the neat thing about 30, 60, and 90 triangles is that the opposite of the 60 is something times square root 3. So our W is square root 3. So our W is 3. This is already square root. So, and the neat thing, also neat thing about it is that for the 60, the difference between the side length of the 30 and the 60 is that the 60 is is the number of the 30 times square root 3. So if this is K square root W, this is going to be K. Okay, so now if we're looking for the 90 is just the 31 times 2, so it's just K times 2, so it's 2K. Now to add together, so 2K plus K is 3K, and our sum is less than 30, so K has to be less than 10. So K cannot be 0, so it's going to go from 1 to 10. And K has to be integers, is what it said in the question. So, I mean, 1 to 10, I mean, it's not going to include the 10, it's 1 to 9, I'm sorry. So the sum from 1 to 9, you could just add up in your calculator. It's going to be 45. And the reason I know this is it's good to know the sum from 1 to 10 is 55. So you want 1 to 9, you just take away the 10. So it's just 55 minus 10 is 45. So it's good to know because sometimes you need to know your basic arithmetic sums. Okay, number 5. The width, length, height of a rectangular solid is 8, 15, 144. The length of a diagonal of a rectangular solid is 108.75. Find the width of the solid. So the diagonal of a solid is just going to be the width squared plus the length squared plus the height squared and then square root the entire thing. And that will get your diagonal. So we have, since these are the ratios, to get to the actual length from the ratios, it's the ratio times a scaling factor. So let's say our scaling factor is x, so it's 8x squared plus 15x squared plus 144x squared. Take the square root of this entire thing, and that should be 108.75. So first we need to find the scaling factor and multiply that scaling factor by 8 because that's our width ratio to get our actual width. So if you know your Pythagorean triples, you can also do this in your calculator to find x. But if you know Pythagorean triples, is way easier. So 8 squared plus 15 squared, that's 17 squared. So 17x squared plus 144 squared, 17 squared x squared, and 140 squared x squared square root equals that. And this is also another Pythagorean triple, the 17, 44, 144, 145. So 145 squared x squared square root is equal to that. So basically, square root of this is 144, 145x is equal to 108.75. You can test it out, it's true. So do 8 squared plus 15 squared plus 144 and then square root the entire thing and use to get 145 on your calculator. So now we just need to find x, which is 108.75 divided by 145, gets you 0.75. Now our width is 8 ratio, so 8 times 0.75 to get our actual width, which is 8 times 0.75 is 6. And that is your answer for number 5. Okay, number 6. In the given diagram, AB is parallel with CD. And they say BDC is x, ACD is x plus 10, and EAF is 140. Okay, so find ABD. So we need to find this one. So if this 140, that means this is a 40 and this is also 140. So if this is 40, that means this angle is 40. Since x plus 10 is equal to 40, then basically x is 30. So this is 30. So now we have a quadrilateral and we could just add things together. So 140 plus 40 plus 30 plus the mystery angle is equal to 360. So that's 70 plus this is 210. 360 minus 210 is 150. So your angle answer is 150 degrees. Okay. Number 7. 2 points are chosen on the circumference of a circle. Find the probability that the chord connecting these 2 points is longer than the radius of the circle. So, okay, so let's have some kind of circle and center. So, if we're choosing 2 points, that means one of the points could be fixed. So, because it doesn't really matter where it is, because if we choose 1 point here and then we choose a 1 point here, and then we choose 1 point here and we can move these 2 points around, it's basically the same thing as saying one point is moving while the other one is like staying the same. And the reason is because you could also just move this one over here. Let's say we have like two of these here, right? Or you could just move this a little bit and it goes over here, right? And this one could also move the same amount to go over here. It's the exact same thing, so it doesn't matter. So you can keep one the same and move the other one and see how it works. So connect this, and that's your radius. Okay, so if we had to have like a point right here, right? And we connect it, this chord is longer, obviously longer than our radius. So how do we get it? So what is the minimum distance that you could go for the radius to be the same along this arc, basically? So if we had to draw it, so let's say this radius, so we had to match it somehow to like a point. We have somewhere like around here-ish. They're about the same length. So that's our radius. And now we connect this one. This is also another radius. So what does that tell us? This tells us it's equilateral. So 60 degrees here. And this is 60 and this is 60. But these don't really matter. We just need to work about this 60. And we could do the same thing here because if this is fixed, we don't need to always have to go to a right. We could also go to a left. So we have another point right here. And that is our radius, and this is our radius as our chord, right? And this is also 60 degrees. So that tells us that anywhere inside this range, if we had to draw a point, it's got to be less than the radius. So if you think about it, we put something right here, right? This line length is obviously less than our radius. So that means everything outside of it, outside the equilateral, because then it's going to be higher, it's going to be obtuse. That means the length of the chord is going to be bigger than the radius. So it's this entire thing. So if this is 60 degrees and this is 60, and the entire thing is 360, then it's 360 minus the 60 plus 60, which is 120, is 240. So the 240 degrees of this is going to be higher than the radius divided by 360. And that should simplify to 2/3. And that's your answer for number 7. So it's really good to, for these questions, to think about it in a picture form to understand what's happening. Number 8. A regular hexagon is inscribed in a circle with circumference 24 pi. If a point is chosen at random from inside the circle, find the probability that it also lies inside the hexagon. Okay, so we have a circle and we have a hexagon. So, and something like this. Not the best artist, but decent enough. So a hexagon is just made by 6 equilateral triangles. So this is 60 degrees. So since it's made by equilateral triangle, that means this is the radius. So what is our radius? Well, 24 pi is 2 pi radius, so our radius is going to be 12. So what's the area of an equilateral triangle? Well, the formula is x squared times square root 3 over 4. So x is the side length, so it's 12. So 12 squared is 12 divided by 4 is 3. 3 times the other 12 is 36 square root 3. And that's only one of them. Remember, a hexagon is 6 of them. So when you multiply this by 6, which is 216 square root 3. So that's the area of our hexagon. Now we need to find the area of the circle. The area of the circle is just pi radius squared, so it's just pi 12 squared, right? So the reason we found these two is that if we choose a point inside the circle, which means the area of the circle, what's the probability that's inside the hexagon? Means that the area of the hexagon over the area of the circle. So we just need to find this probability. So we could just put it on our calculator. So 216 times square root 3 divided by pi times 12 squared. And to the nearest hundredths is 0.83. And that's your answer for number 8. Okay, number 9. Triangle ABC is isosceles with AB is equal to AC, and CM and BN are medians such that CM is perpendicular to BN, and the base of ABC has a length of square root 6. Find the perimeter of ABC. Okay, so let's draw the picture. We have two medians, 90 degrees. So this is square root 6. Okay, so since these are two isosceles, that means it tells us that the median are also the same length. That means this and this are also the same length, logically, right? So if these are the same length as this 90, that means these two angles are the same. That means both of them has to be 45 degrees. Okay. So you don't really need to like kind of prove it logically. If you do geometry for competitions, you want to think about it logically so you could move faster and save time. So we know this is 45 degrees. So if this is 45 degrees, if this is for 45, 45, 90 triangles, basically 45, 45. If this is x and this is x, this is going to be x squared root 2. Okay, so it's just x times the square root 2. So basically this is 45, 45, and we already have the hypotenuse of square root 6. So that tells us that this is square root 3, and this is also square root 3. Okay, so to get the side, since we already have one of the side length, which is square root 6 is given to us, we need to find these two right here. So to do that, we could use the Pythagorean theorem. So we could just make a height. And if we get the height here, and we take the Pythagorean theorem, we could get this length. So we already know this length, that's just square root 6 divided by 2. And now we need to get this length. So if you think about it, since we cut it from here, and it's a isosceles triangle, basically it's cutting right between, and it's going through that point, logically speaking. Which also makes sense because three medians of a triangle always intersect at one point. And this point basically tells us that since this is going through the right triangle, and we make a right triangle here, if this is 45 and this is 90, that means this is also 45. So now we have another 45, 45, 90 triangle. And now your square root 3 is your x square root 2. So our x here is going to be square root 3 divided by square root 2. So that's the length here. Or you can rewrite it as saying square root 6 over 2. And that's your length here. And now this length, a cool property about medians is that the ratio of this length to this length is 1 to 2. 1 to 2. Okay? So if you want to have the entire length, if this is 2 times this one, then to add them together, it's a 2 plus a 1 is a 3. So you got to multiply this side length by 3 to get the entire length of the height. So that's 3 square root 6 over 2. And now we have the Pythagorean theorem. So square root 6 over 2 squared plus 3 square root 6 over 2 squared, which is just square root 6 over 2 because there's both of them here. So we have 1/2 squared plus 3 over 2 squared. So that's 1/4 plus 9/4, which is 10/4. And then that's just times square root 10 over 2. Okay. So square root 6 and square root 10, that's just a square root 5 and a square root 3. Because square root 2 times square root 2 is 2, so we can knock out one of these 2's. And then 3 times square root 5 is square root um, square root 15. Oh, sorry, there is another one here, it's just square root 10. So we just had square root 15. Sorry about that. There was an extra 2. Okay, so square root 15. And what we have, square root 15 here and square root 15 here. So we add them all together, square root 15 plus square root 15 plus square root 6. That's 2 square root 15 plus square root 6. And that is your answer for number 9. Number 10. A circle is inscribed in ACE. Angle E is a right triangle. Okay. ACE. Wait, sorry. A, E, and then C. And then there's a circle inscribed in it. So something like this. Yeah, I'm not the best artist, but that's exceptionally bad. Okay. And B, D, F are circle points of tangency on AC. So B is here. D is on CE. And F is on AE. if CD is square root 45, so that's just 3 square root 5, basically be divisible by 9. So square root 9 is 3. And then square root 20, which is 2 square root 5, is AB. So what this basically tells us is that external lines have the same length. So this is also 2 square root 5, and this is also 3 square root 5. And this length, these lengths, they're the radius. Because if you think about it, if we draw a center of the circle and we draw these lines, since this is tangent, this is 90, this is tangent, this is 90, that means this has to be 90. That means this is a square because this is the radius and this is the radius. So that means these two are also the radius. So that's like a quick way to understand stuff. You don't have to prove it in the contest because you don't have the time. So all you have to do is just draw a diagram and think about what's happening. So we have the radius plus 2 square root 5 squared using your Pythagorean theorem to find your radius. Then radius plus 3 square root 5 squared is equal to 3 square root 5 plus 5 square root 5. I mean, plus 2 square root 5 is 5 square root 5. And then 5 square root 5 squared is 5 times 5 times 5, which is 25, 125. Okay, now to distribute that, that's r squared plus 4 square root 5r plus 20. And then this one is r squared plus 6 square root 5r plus 45. And that's equal to 125. So that's 2r squared plus 10 square root 5r. This is plus 65 minus the 125, so that's minus 60. It's equal to 0. Okay, let's move this up. Because we just need, for number 10, we just need to find the area of the circle. So we just need to find r and then pi r squared. So now we divide by 2. Minus 30 is equal to 0. So you can use the quadratic formula or any way you like to do to find r, because it's a quadratic now. But what I like to do is usually I like to find the vertex form. So it's 5 square root 5 over 2 squared. So they give us the first two terms. Now we need to get the constant. So 5 squared times 5 is 125 divided by 2 squared, which is 4. So 125 over 4. Positive, but we need a negative. So 30 is negative 120 over 4. So to get from 125 to negative 124, we got to minus a 245 over 4 equals 0. Okay, and that's usually how I like to think about it. And now to move this, and then if you move this to the other side, it becomes positive, and then you take the square root because it's squared. So square root of 245, and then square root of 4 is 2. And then you have to minus the thing that's inside, which is 5 squared 5 over 2 to get our radius. So what is 245? Well, 245, if you divide by 5, that is 2, a 4, and a 9. So that's 49. So this is actually 7 squared 5. So 7 squared 5 minus 5 squared 5 is 2 squared 5 over that 2. So it's actually square root 5. So your radius is equal to square root 5. So that means pi radius squared, which is your area, you just square this, which is 5 pi. And that is your answer for number 10. Okay. Number 11. Find the perimeter of a rhombus with diagonals 9 and 16. So this should be pretty simple. So we have a rhombus, and these are our diagonals. So longer one 16. So let's call this one 16 over 2, right? Because we need to cut it in half. And the diagonal here is 9 over 2. So the two diagonals of a rhombus are perpendicular. So to get the side length, we could just do the Pythagorean theorem and then multiply by 4 to get the entire thing for the perimeter. So we just do this on your calculator. So 9 divided by 2 squared plus 16 divided by 2 squared. And then you take the square root, it is square root 337 over 2. I recommend not writing the square root in your calculator because then you get 337 over 4. And then square root of 4 is 2, and 337 is prime, so you get this radical. And then that's just the side length, so we need to multiply by 4 to get the entire thing. So 4 and 2 cancel out to the 2, so 2 times 337. And that is your answer for number 11. Whenever they have a question like this and they say never say to you write as a decimal, you have to write it exactly as this, as a radical. Number 12. Illinois math is a regular hexagon with a perimeter of 54. Find the length of the radius in the inscribed circle in MTH, triangle MTH. Write your answer in reduced simplified radical form. Okay, so and something with a circle here. Okay, so we have a perimeter of 54. That means it's a hexagon. We divide by 6. That means each of these are length 9. I'm not going to label all of this, but basically this is 9. So what you need to know is that you ignore everything but the hexagon and this line cuts right in half of this shape. So if the angle of a hexagon is 120, that means this angle right here is 60 because it's cut in half. So since this is 90 and this is a triangle, that means this is 30. So it's a 30, 60, 90 triangle. So opposite of the 30 is 9. So opposite of the 60 is just square root 3 of the 31, which is 9 square root 3. And opposite of the 90, which is our hypotenuse, is just 2 times our 30, which is 18. 2 times 9 is 18. So to get this radius, which is what they're looking for, there is a formula for this, and it's called the in radius. It's actually just the area, 2 times the area divided by the perimeter. So the area of the triangle and the perimeter of the triangle. So 2 times the area is 9 times 9 squared root 3 over 2, right? And then our perimeter is going to be equal to 18 plus 9, which is 27, plus 9 squared root 3. So let's simplify first before we do some big multiplying. So 2 and 1/2 cancel each other out. And this 9 could cancel with this 27 to make a 3, and this 9 to make a 1. So we have 9 square root 3 on the top, and the bottom we have 3 plus square root 3 on the bottom. And now we can multiply by 3 minus square root 3, 3 minus square root 3. So 9 times 9, 3 times 3 is 9. Square root 3 times negative square root 3 is negative 3, so that cancels out to a 6. Cancel out this 3 with a 2, and then cancel out this 3 to make a 3. So now 3 square root 3 times a 3 is 9 square root 3. And 3 square root 3 times negative square root 3 is minus 9. And then we have a 2 on the bottom. So your answer is 3 square root 3 minus 9 over 2. Number 13. In triangle ADC, BD bisects angle ADC. Okay, so let's draw this first. So this angle is equal to this angle. And AD is 2 times of CD. Okay, find the ratio of BC. So we need to find the ratio of this length. Let's call it L to AC, which is the entire thing. And let's call it M. So we need to find L to M. Okay, so you only need to use a single formula for this, which is called the angle bisector theorem. So if an angle is bisected, so these two angles are the same, then the ratio of these two side lengths is going to be the ratio of this to this. Okay, so the ratio of these two is going to be 2 to 1. So that means the ratio of L to M, 1 plus 2 is going to be equal to M is 3. So the ratio from L to M is 1 to 3. And that's your answer for 13. Just basically that simple. Number 14. Circles of radius 4, 5, and 6 are mutually exclusive, mutually tangent externally. Find the area of the triangle formed by connecting the center of these three circles. Okay, so circle 1, circle 2, and let's say this is our last circle, circle 3. Okay, so this put the centers together, and then we need to connect them to make our triangle. So the smallest is the 4, the medium is 5, and the largest is 6. So our side length are plus these is 9, plus this is 11, and plus this is 10. Okay, so to get a area of a triangle using only a side length, we gotta use something called Heron's or Hero's formula. So basically all you have to do is add the side length all together. So that's 9 plus 11 plus 10, that's 20, 30. and then have that number divided by 2. So 30 divided by 2 is 15. Write that down. Now have that number subtracted by either these three numbers. So 15 minus 9 is 6, minus 4 minus is 5. Now have these numbers multiply all together and then square root them. So 15 times 6 times 4 times 5. So what I like to do is look for pairs. So 5 and 15 here makes a 5 with the extra 3. And 4 has a 2 because it's a perfect square. And the 3 and the 6 here leaves a 2 here to make a 3. So 5 times 2 times 3, that is 30. And the extra 2 makes a square root 2. And that's your answer, 30 square root 2 for number 14. Number 15. A, B, C, F, and D are parallel, where AB is 16 and DE is 24. Find the length of CF. And then write as a radical, as a decimal, I mean. And something like this. Okay, and this is 16 and this is 24. And let's call CF H, and let's call these individual parts AB. So what we could do is think about similarity of these triangles. So the big triangle, 24 over A plus B, right? This entire big triangle, the ratio of the height to this base is equal to this height to this base, which is H over A. Now we do the same thing for these two triangles, which is 16 divided by A plus B is equal to H divided by B. Or if you want to think about it, we need to cancel out A plus B, right? So what we could do is that we could switch the top and the bottoms, make A plus B over 16 is equal to B over H. And now we can multiply these two together. So then the A plus B cancel each other out, and the 24 over 16. And the H cancel out, and we have a B over A. So that gives us the ratio of our B to A. So divide by 8, 3. Divide by 8 is 2, so 3 over 2. So 3 over 2A is equal to B. So this one is equal to 3 over 2A. So that is good to know. And now let's delete over all these. So now we're going to do the same thing again. So 24 and then A plus B, but B is now 3 over 2A. So 1 plus 3 over 2 is 5 over 2A is equal to H, which is what we're looking for, and then over A. So we could cancel out the A because they're on both sides of the equation. So H is equal to 24 divided by 5 over 2, or it's 24 times 2 over 5, which is 48 over 5, which is 9.6. And that is your answer for number 15. So you just think about similarities. Number 6. In the given diagram, BA, AC, CE, and ED are the same. Okay, so we have 1, 2, and this equals this equals this equals this. And DAB is 110. This might be a little bit small, so let's draw a little bit bigger. Okay, so these are the same. So let's call this x and this x. So this is 180 minus 2x, right? So the sum is 180. And they're isosceles, and that's why it's that. And they say DAB, so this angle is 110. So this has to be 2x, cancel out this negative 2x to minus 70 to make that 110. And since it's isosceles, so this is also 2x minus 70. And these are 2x is 4x, so this one has to be minus a 4x. And then this is a minus 140. To make a 180, that means this has to be 320. And for this to be 180, right, this 2x minus 70, this has to be 250 minus 2x. And since this has to be minus 2x, and these two are the same, that means 2x divided by 2 is negative x. So we have a negative x to go for both of them that we need to cancel, so these has to be positive x's. And the 250, we need to make it into a 180, so that's an extra 70. So we need a minus a 35 from each of them. Okay, so now we have everything. And those were just for the small triangle. Now for the big triangle, we need to add this plus this plus this to get our 180, right? So x plus, and this angle they already gave us, DAB, is 110. plus x minus 35 is equal to 180. So this is 2x minus 35 is equal to 110, 180 makes 70. So x is equal to 105 divided by 2. So now we need to look for CED. So we need to look for this, which is 250 minus 2x. So we already have our x. We could just plug it back in. So 2 times 105 divided by 2, that's 105. So 250 minus 105, that is 145. And that is your answer for number 16. Number 17. A triangle is selected at random from a set of triangles with integral degree measures for which the ratio of the degree measure of the angles is a to b to c, where a, b, c are consecutive positive integers. Find the probability that the degree measure of the largest angle is an odd number. Okay, so since a to b and c are consecutive positive integer, we could just write it as x plus 1 to x plus 2. But what we could do now is that since these are ratios, they don't necessarily have to add up to 180. So we had to have a scaling factor. So scaling times the sum of these, which is x plus x is 3x, plus 1 plus 2 is 3, is equal to 180 as our degree angle. And then we divide by 3, so that's x plus 1 equal to 60. So that means s and x plus 1 are factors of 60. So the factors of 60 are 160, 230, 320, 415, 512, and 610. So x could be any one of these 12 numbers, and it cannot be 1 though. And the reason is because x plus 1 equals 1. That means x equals 0. And x cannot be 0 because it's a ratio. So it has to be at least 1 or higher. Or, yeah, 1 or higher, because they said it was an integer. So, and they also said they want this to be an odd number, right? The largest value. So that tells us for it to be an odd number, this has to be an odd number, but the scaling factor also has to be odd. And the reason is because if you have this as odd, but this is even, that means an odd ratio times an even scaling factor means we have an even degree measure basically. So for it to be odd, it has to be an odd times an odd. So basically, if x plus 2 has to be odd, that means x has to be odd. So if x has to be odd here, right, because x is odd, x plus 1 has to be even. So we have to look for evens. So that's a 2, a 4, a 6, a 10, a 12, a 20, a 30, and a 60. But remember, we need to look for when our scaling factor is odd. So our scaling factor is the opposite number. So we have 2 and 30. Okay, so these two does not work because they're even scaling factors. 60 work because 1 is an odd scaling factor. 20 works because 3 is an odd scaling factor. 4 works because 15 is a odd scaling factor. 12 works because 5 is a scaling factor. And 6 and 10 are even, so they both don't work. So we have a 60, a 20, a 4, and a 12. So that's 1, 2, 3, 4. Out of how many that work? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? It's not 12 because 1 does not work. So our answer is 4 out of 11. And that's our answer for number 17. So it takes a lot of logic to work through it. And I worked through this already, so I kind of have an understanding. But if you kind of like slow down the video and think about it for yourself, it makes sense. Number 18. Two triangles are similar but not congruent. The length of all sides of both triangles are integers. So they're all integers. Let's draw two triangles. The first triangle has sides 9 and 32 and a perimeter of 68. So that's 41. So 68 minus 41 is 27. If one of the sides of the second triangle, okay, is the same as one of the sides of the first, find the perimeter of the second. So let's say the one that's the same as 9. 9 cannot go with 9, cannot go with 32 because they're not multiples, but it could go with 27. So you put 9 here. So we need to divide by 3. So 9 divided by 3 is 3. 32 divided by 3. Okay, that's not an integer, so it doesn't work. So 9 doesn't work. 32 doesn't work because there's no multiples of it. 9 and 32 are not multiple. 27 is not 30, are not multiples of 32. And 27 is a multiple of 9, so we could put that here. And it works because an integer multiplied by an integer is going to be an integer. Because 27 is scaled up 3 by 9. So it's just the perimeter of this triangle multiplied by 3 to get the perimeter of the second. So the perimeter of the first is 68, multiplied by 3, and 180, 24, that makes 204. And that's your answer for number 18. Number 19. ABC is a rectangle with AB is equal to 20. So that looks decent enough. And E and F are located such that AECF is a rhombus. Find EF. Okay, so we need to look for this length. Okay, so first off, since this is a rhombus, let's first find the side length of the rhombus. So let's label this X, and this is 20 minus X. So since this is a rhombus, that means this side length is also 20 minus X. So now we could use the Pythagorean theorem, which is x squared plus 12 squared is equal to 20 minus x squared, which is just 400 minus 40x plus x squared. We cancel out the x squared, so it's just 400 minus 12 squared, and then divide by 40 to get our x. So our x is 32 over 5. Okay, so if our x is 32 over 5, then basically to get our rhombus side length, which is just 20 minus x, so it's just 20 minus 32 over 5, which is 68 over 5. Okay, so how do we get this length? Well, basically, if you think about it, from question 11, right? We did the process where we have the diagonals, half the diagonal here and half the diagonal here, did the Pythagorean theorem to get our side length. Now we're going to do the reverse process because we have the side length, but we're looking for the diagonals. So what we're doing for 19 is basically we had to find this diagonal. So that's just the diagonal of the rectangle, which is square root 20 squared plus 12 squared. Using our calculator, 20 squared plus 12 squared, and that is square root 544. Okay, and that's the length of this. Now, we only need half of it, right? Because we don't need the entire thing, we need half. So square root 544 squared. Oh, divide by 2. And now this length, right, triangle, right? And then half of the length that we're looking for, so we'll just call that L first, L squared, plus this thing squared, Pythagorean theorem, equals 68, our side length, which is 68 over 5 squared, right? So now you can just do this all in your calculator. So 68 divided by 5 squared minus square root 544 divided by 2 squared, and then take the square root of that number to get our length, and then multiply by 2 to get our entire length of this, which is going to be equal to 13.99 with 4 significant figures. And that's your answer. Okay, number 20. A rectangular sheet of paper 40 centimeters by 70 centimeters is folded once so that the opposing corners are coincident. Find the number of centimeter in the length of the crease. Okay, so they actually gave you a hint to how to solve this, and it's in question 19. If you look at the picture and you take the point C and move it to point A, right, and you fold it like a piece of paper, right, the crease of EF, that's the crease of the paper. So that's basically what we're going to be doing. So all we had to do is now instead of using 20 and 12, we're using 40 and 70. So it's just the same question again, but with different numbers. But now instead of rounding, they want the precise answer. So they want you to know how, they want you to do it again, but more precisely. So I'll put the 70 on top because I usually like the longer numbers with the longer side. Makes sense logically. So that's 70 minus x, and we're going to do the same thing again. So x squared plus 40 squared equals 70 minus x squared. So that's 4,900 minus 140x plus x squared. Cancel out your x squareds. So 4,900 minus 40 squared divided by 140, and you get x is equal to 165 over 7. Okay, so we have that. We'll delete this. So now we get our 70 minus x. So 70 minus 165 over 7, we get 325 over 7. And now to get the length of our thing, 90 degrees, right? So get the length of our hypotenuse. 70 squared plus 40 squared, and that square rooted, you should get 10 square root 65. Divide by 2, right, to get 5 square root 65 as this length. So 5 square root 65. Okay. So you should be doing this on your calculator. It takes too long if you're doing by hand. So we call this L. So 5 square root 65 squared plus L squared is equal to your length of the rhombus, which is 325 divided by 7 squared. And now we just 325 divided by 7 squared. It's 5 times 65. So we get a 26,000 over 49 is equal to L squared. So taking the square root of this, square root of this would be 10 square root 260 over 49, and then as equal to our L. And now square root of 260 divided by 4 leaves us 65. So square root of 4 is 2, so that is 20 square root 65 over 49 is equal to L. So that is only half of it, so we want the entire thing for our crease. So we multiply by 2 to get 40 square root 65 over 49. And that's your answer. 40 square root 65 over, sorry, not over 49. I forgot to square root the 49 on the bottom here to make 7. So it's 40 square root 65 over 7 is the length of your crease. Okay, and that covers everything for our 2014 Division A geometry. So, overview, basically know your properties of your shapes, the basic ones, even, and your special right triangles, which is the 45, 45, 90, and your 30, 16, 90 triangles. Um, Understand ratios, basically. They have a bunch of ratio questions this time, and yeah, and relationships and similarities. Tangencies, more ratios, more polygons. No radius and circumradius. They didn't cover circumradius in here, but basically you should know it because they have radius here, which is this. This is inscribed, so radius inscribed. And basically a bunch of Pythagorean theorems. Probability, just draw pictures for like 7 and 8. And then everything else, which is pretty simple in the beginning. But that basically covers everything. Well, thanks for watching, and I'll see you at the next math record.